Here we're going to find the horizontal and vertical asymptotes of the graph of this function. It's got a square root in it, so we got some work to do. So the vertical asymptotes, we've learned that one before, and for that one, for vertical asymptotes, we just set the denominator equal to 0 and solve. So setting 2x minus 5 equal to 0, we get x equals 5/2. So that's our only vertical asymptote. We could look at its behavior by looking and doing a sign test on both sides of the asymptote of x equal to 5/2. On the left-hand side, we can see, let's see, this is 2.5. So I'm going to do a test point of 2 here and a test point of 3 here. So if we test out a 2, well, we know the numerator is always positive. So we really just have to check the denominator. So plugging in 2, we get 2 times 2 is 4, minus 5 is -1. So this is negative, which means my end behavior here must be going down. And then plugging on the right-hand side of that asymptote, testing in the 3, again, I always get a positive in the numerator here because it's the square root. Then I get 3 times 2, which is 6, minus 5, which gives me a positive 1. So this is positive, which must mean my asymptote is going up on the left. So I get a limit as x approaches 5/2 from the left equals -infinity, and the limit as x approaches 5/2 from the right to be equal to positive infinity. So that's my vertical asymptote information. So now for the more challenging one, now let's find out about the horizontal asymptotes. So this one, we need to do some tricks. So we need to do the limit as x goes to infinity. Just rewriting the problem right now. Now remember, the rule is to divide every term of both the numerator and denominator by the highest power in the denominator. So that is just x. So that is the same thing as multiplying by 1 over x for the numerator and denominator. And that gives me that's my numerator. And then for the denominator, I have 2x minus 5 over x. So my denominator is easy enough to decompose, and I can just split that up into 2x over x minus 5 over x. But the numerator, I have a square root, and I can't bring that x into the square root because it's not a square root. So what I can do is I can replace this x with a radical or a square root of x squared, because that is the x almost. So this is equal as long as x is a positive, which it is right now because we're approaching positive infinity. If x was a negative number, then once I square it, I make it artificially positive and take the square root of it. And now I've taken away its negativeness. So what I want to do is I want to use a radical x squared, so I can bring it into the square root, the 36x squared plus 1. And I want to use positive radical x squared for when I'm looking for x approaching positive infinity. And later, if I'm trying to find x approaching negative infinity, then I'm just going to use a negative. So I know if x is supposed to be positive or negative based on what numbers I'm plugging in, if I'm going to positive infinity or negative infinity. So that's the trick that I'm going to use here. So I'm going to replace that x with a radical x squared. And since I'm going to positive infinity, I use the positive radical x squared. And that, now I can bring that into the square root with the 36x squared plus 1. Now I can take that square root of the whole thing. So now I have square root of 36x squared over x squared and plus 1 over x squared. So decomposing, so putting the whole thing, that square root over the whole, both the numerator and denominator, and also decomposing the fraction in that step. And then I'll just copy down the denominator here. So now I can start to reduce some things. So I can see that an x squared and x squared here will cancel, just leaving me with a square root of 36. And the x and the x will cancel, and I just have the 2. Okay, so I'm going to write that in a step. So we have square root of 36 plus 1 over x squared over 2 minus 5 over x. And then I remember the rule that the limit of one, any constant over any power of x equals 0. So that means this equals 0, the limit of that equals 0, and the limit of that one equals 0. So that just leaves me with a radical 36 over 2, which equals 6 over 2, which equals 3. And I just realized that I took my limit out a little bit early because I did not take the limit there until the very last step. So I do need to write, these are all limits. And then at that last step, I took the limit of those numbers, and I got 3. So that gives us one of the horizontal asymptotes. So we know it as x goes to positive infinity, or as it goes to the far right, we get 3, which gives us the asymptote x equals, the horizontal asymptote is going to be y equals 3 is one of our asymptotes. We got the vertical asymptote at x equals 5 over 2. So that's another asymptote. Remember, our question was to find all those asymptotes. So there's our vertical one. There's only one vertical one. There's one horizontal one, but it looks like we'll have another horizontal one, or maybe. Let's test. We only checked positive infinity. So now we need to test what happens to the graph when x goes to the far left. We checked the far right and it went to 3. And now what happens when we go to the far left? So we have the same beginning. And again, we're going to multiply both sides by 1 over x. And again, we get the limit as x goes to negative infinity of radical 30x squared plus 1. And we're dividing everything by 1 over x. But this time, when I substitute in my square root of x squared in for x, so that I can bring everything under the square root, this time I want to use the negative version, because this time I know that I'm plugging in a negative number for x because I'm on the far left side of the graph. So this time when I do my substitution, I'll write a negative radical x squared. So that's the only change I really make, is I'm going to have a negative there. How does that affect my answer? Well, let's see. So breaking this up and bringing my x squared into my square root and decomposing my fractions, I get the square root of 36x squared over a negative x squared and a 1 over a negative x squared. Whoops. In the denominator, I get 2x. That denominator doesn't change. 2x over x minus 5 over x. So I have some things that reduce. My x squareds will reduce, but I still have a negative there. So it's a negative 1 now. And the x's reduce. So I just have a 2 now. And when I take the limit, this goes to 0, and this goes to 0. Which gives me the limit as x approaches negative infinity of the square root of 36 divided by negative 1. I'm sorry, that negative should be on the outside of the square root. Whoops. Both those negatives should be on the outside of the square root. See how it's on the outside of the square root here. So it should be on the outside of the square root here. So it's actually a positive 1 on the inside. That plus 0 over the 2. So that gives me a negative square root of 36, which is 6 over 2, which gives me a negative 3. So it looks like I have another horizontal asymptote as x goes to the left of y equals negative 3. So now I have 2 horizontal asymptotes and 1 vertical asymptote.